congratulate you on your 25 years of independence. I think that's a great moment in your history, and I offer my congratulations to you. I've had the privilege over the last several years to work in an international context through the international studies called TIMSS and PISA. And in that respect, I have had the opportunity to learn a great deal about countries and their performance, and I have focused in that work on mathematics. And I've noticed two things that tend to be true across the world, across all of these countries with whom I have worked. And that is, first of all, countries are concerned about their status in the world. In an increasingly technological global economy, countries care about their average performance and how that pegs them with respect to other countries. I noticed the last presentation gave some of those statistics about competition. But the kinds of competition I'm referring to are not among the elite, the intellectually most advanced, but it is a representative sampling of each country, and therefore characterizes the country as a whole. So basically, I want to share with you some of the things I've learned in that context. And as I said, the first one is an international notion of excellence. How well do our students compete internationally? But the second thing that I think is just as important is the increasing concern that countries have about the inequality between those who are more well-off and those who are less well-off, between the higher social classes within a society and the lower social classes. And this gap that we hear about among, in virtually most all of the countries of the world, is the concern that that gap is widening. You read about it in various publications from economists. The income gap is growing between the segments within a society, as is the wealth gap. And these are serious concerns for democratically oriented societies when that gap gets too big. Well, there's a related gap I'm going to argue and to show you, and that related gap has to do with education, that there are actual gaps in what happens in school as to who gets to study what. And I want to show you that those gaps are serious and important, not only to their performance, but ultimately to issues such as social mobility. I'm going to focus on an important part of this, curriculum. Every country that I've ever studied, across the 80-some, they have standards. Standards define what children should learn at each particular grade. I'm going to focus on mathematics. Mathematics is probably ever so increasingly important in today's world. It's the new literacy. The technological world, the cosmos, as some have written, is run by mathematics. And so increasingly we find mathematics as a much more central part of life. And that literacy, together with the traditional literacy related to language, I think are the two major literacies that make a difference for a society and make a difference for children in their future and how well they will succeed. And as we talk about mathematics, one of the issues is in the 21st century skills, which we also talked about in the first session, it becomes important not just whether they know algebra and know what a quadratic function is, but it's that they are able to use that mathematics in the real world. They can apply it to solve problems and to understand the things that go on around them in their world. So what I want to focus on is that aspect of mathematics. And the PISA study, which I heard earlier, is in fact has a very important role to play in this issue. They have defined their test, the PISA assessment, an international test given to 15-year-olds across the world. The last administration was across 60-some countries, in which Kazakhstan was included. This is the goal. This is the way they think of mathematics literacy. As you move from some practical problem in the world, you then turn it into mathematics. You solve the mathematics and then return to the problem. The steps that are really critical are turning an ordinary problem into a quantitative problem, if that's relevant, and then interpreting it back into the real world. So this is what drives the definition of mathematics literacy from the PISA point of view, which I think gets quite close to the kinds of things we're talking about. Now this next slide is very technical, it looks technical, and essentially is, but I will tell you what it says. That when we look across all those 60-some countries, the opportunities students had to learn mathematics, the formal kinds of mathematics that's included in the curriculum of schools, the better they did. And this was true across countries. It was true across schools within countries, in every country that was in part of the study, and it is true within schools across the students as to the different opportunities they have had. So we know schooling matters. That's why when you were talking earlier, the speaker was talking about the new curriculum. You need to realize it's probably one of the most important things you could possibly do for the children of your nation. The curriculum matters. Schools matter. And what matters is what we teach them and the opportunities to learn that we give them. And so basically, this slide shows the relationship of the opportunity to learn to the performance of the students in that country. And you can see that the height of that tells you how strong a relationship there is. And you can see that on the far end, it's around 70, meaning 7/10 of a standard deviation, a very large effect, like Korea. But then you'll notice the average across the OECD countries is about 40. And the yellow is Kazakhstan, which is about 20. So one conclusion there is that, and it is statistically significantly related to performance in Kazakhstan, but the curriculum that was in place in 2012, its impact on the PISA assessment on that mathematics literacy was not as strong as many of the other countries. And perhaps the curricular reform that's being talked about might change that. But there's another aspect. We not only studied the formal mathematics students had, but how much they actually worked with applied problems. If you want them to apply mathematics in real world, then you would think that applied mathematics would make a difference. Well, this slide shows that it's curved. Put simply, yes, applied mathematics, as students work with their formal math but apply it in school, there is a gain for that. But at some point it levels off, and at another point it drops. So there's a balancing act here. The amount of applied mathematics cannot go on forever. There is a point at which more applied mathematics probably draws from the formal mathematics and then therefore begins to hurt the performance of the students. So there's a balance to be had. But bottom line, what this shows is it really matters. The curriculum does matter. And the formal aspects of mathematics, like learning algebra, like learning geometry, does matter even to a problem-solving literacy type test. That's not so obvious. And some would have argued that not to be the case, that more the applied math matters. Well, they both do. But the stronger effect comes from the formal mathematics. Put simply, you cannot do applied problems without a good foundation in mathematics. So the curriculum needs to provide that in a strong way for the students to succeed. The next slide shows you what is the second matter. So what I've described to you so far says, yeah, excellence can be achieved through a curriculum that is demanding. It has formal aspects, but also applied aspects, if your concern is mathematics literacy. Now I want to turn to the second most important issue, which has to do with the issue of equity. This slide shows the variation in opportunity to learn mathematics within each country. And again, you can see Kazakhstan is on the lower side. The red is the average of the OECD, the wealthiest countries. And you can see there's a lot of variation, but there is a lot of variation. There is variation as to which kids get which opportunities. The real question is that related to social class. And to look at that, we look at this slide, which says, in fact, that SES, the social class within each country, not across countries, but within the country, that is the differences across students within Kazakhstan, the yellow, says what impact does that have on performance? All of those are statistically significant. Now, the good news for Kazakhstan is that the amount of impact of social class is on the lower side of most countries. That is, SES is not as strong, has not as strong a relationship. But from a world point of view, and this slide just has some of the countries for whom we have those data, it says that basically there is a curriculum gap that's created by social class. And there's a performance gap that's created by social class. So if you look at the top quartile, 25%, and the bottom quartile, and look at the difference in performance and the difference in what mathematics they study, you find that they're related, strongly related. Put in simple English, it's a matter of different children of social classes get to study different schooling, different mathematics, and the consequence is they learn different amounts. That's not particularly profound, but it's really societally, politically, and morally and ethically a serious issue as to why those differences exist within a society. The next slide is actually the heart of what I want to talk to you about that actually answers the second question about issues of equity. What we know here in this proposed hypothesis is that we have two relationships which I've already spoken to. SES, social class, is related to performance. Think of that as the home family background. In every society, in every country that we studied, this was true. It's statistically significantly related. Kids of lower social class upbringing and backgrounds do more poorly than do the children of the higher social class. That's true everywhere. Now, we also know that the opportunities to learn are also related to performance. That children who get to study more advanced mathematics do better on a test. Again, a fairly obvious statement, but to quantify it and to demonstrate it statistically, scientifically, is what this study enables us to do. So those two arrows, the green one and the whatever that color is, I think it's about some kind of purple, those two arrows we know about. But what I want to show you is there's another arrow, a hidden arrow to many people's thinking about all of this. That arrow goes from social class to opportunity. And that's, if there is a relationship there, what that says is children of different social classes get to study different opportunities in mathematics. And so the question is, does that exist, and to what extent does it exist? Because you see, if it does exist, social class not only has a home family background impact on student performance, but it adds another one through schooling. Because if social class is related to who gets to study what, and the what makes a difference to performance, then social class now gets increased through the schools. So what I'm talking about is the antithesis of what basically every society says about schooling, that it is the great leveler. It is the means to a better life. If the kids come to a country, if they take opportunity and they study hard, they will have a better life. They will succeed. That's what worries most societies about the gaps that they're finding between the wealthy and the poor in terms of income and other, is that this democracy will not necessarily support such gaps if they get too extreme. Many sociologists have written about that. But if in fact the system is unfair, so that the very kids who need the kind of schooling to succeed don't get it, then in fact social class has a double effect, a direct and an indirect effect. And so what we now see is what that is in fact the case. This slide, the light blue, is the background, the effect of social class on performance. The dark blue is what's added through the indirect effect of schooling. So in other words, the light blue is home background, the dark blue is schooling. And you can see that that slide is organized by the background, so it's from the countries that has the highest degree of background social class inequality to the least, as it organizes from the right to the left. But what that dark blue shows is how it's distorted by the schooling inequality. Very quickly, I will tell you one very interesting example. Most countries think of Sweden as being one of having the least amount of social class inequality. The Nordic countries have been very proud of that. But Sweden has more social class inequality coming from the background of the family than does the United States. But the difference is we in the United States add 40% almost through our schools, by the way our schools are structured and organized, the policies which we have. Not by design, I argue probably by unintended consequences. We add that much. In Sweden, they add virtually no inequality through their schooling. The next slide just shows you a different, this is the same slide, it just shows it structured in a different way. This is the total effect from the right on down to the left. And so you can see the countries, France, for example, has the largest degree of social class inequality, the total. This slide actually organizes the same thing, still one other way. The dark blue is now it's organized by, and that shows you as you move from the most inequality contributed by schooling down to the least. But the point is, you can see that home family background is not the only source of inequality. The true irony is the schools themselves, by policies not, I don't believe, designed to, in effect, create more inequality, but the consequences of tracking, of different housing patterns in countries. Every country's consequences are probably from different sources. And so let me skip just right over here to this slide. These are the data for Kazakhstan. And I ask you just to look at the bottom row, since I have very little time. And that basically is the, you can see that's the percent of inequality. And you can see that whereas the international average is something like 32, Kazakhstan is 17, so it has less. But the interesting thing, and I don't have time to explain this, but basically where the inequality is coming from in the schooling here in Kazakhstan is between schools, not among kids within schools. So, and I don't know the system well enough, I can only point, and I would never try to suggest to any country what they should do. But I would suggest you look at the policies, because somehow among schools is where the greatest degree of inequality comes in. And the last thing I want to just show you are these slides. Basically, does it matter is the ultimate question. Well, it does if you believe social mobility is important. That is, the chance for children as they grow up to get a better life from the life into which they were born. And what this shows is there is a strong relationship between measures of inequality and mobility. The greater a society has inequality in its opportunities to study mathematics, the less mobile that society is. And so you see that this educational inequality, which is surprising, hard and life will get better. This says study hard in the right places, make sure you're of the right social class, and then you might have an even greater chance of success. But for the rest of the kids, that may not be the case. So I leave you with that thought, that as you change your curriculum, as you move to a more demanding curriculum to compete in the international arena, make sure that you address the inequality as to who gets to study that curriculum. Because the irony, the saddest irony of all in my mind, is as you increase the quality of that curriculum, if you do not address the basic inequalities that occur through schooling, you will make things worse. Yes, you might improve the average performance, but you will leave more children behind. And I think that's one of the most compelling issues to have arisen from these data. Thank you.